Hi guys, welcome back to my channel Pirai Academy. In this series of Zoho interview question, we are going to see about a new interview question called minimum number of coins. So you will be given the infinite supply of each denomination of Indian currencies like this and a target value n. Find the minimum number of coins and or notes needed to make the change for rupees n. You must return the list containing the value of coins required. Okay, and here is an example. N is equal to 43, which means we want to take two 20 coins and one 2 coin and one coin. That's it. Can you understand this? Okay, which sum up to give 43. Similarly, here 1000. So you want to take two 500 notes. That's it. Can you understand this? Fine. So how to do this? So here we are going to use a greedy approach. Okay, what is the algorithm behind it? So just see this carefully. This is a greater number and this is a lesser number. So if I give, for example, it is something like a 5,000. Then what is the minimum number of coins we should take such that 5,000 will be fulfilled? So I will be taking 2,000 two times, right? 2,000 two times. But there is another possibility. I can take 5,000 1 rupee coin. I can take 5,000 1 rupee coin. Or I can take 2,000 and 500. Can you understand this? I can make only 4 notes, or I can make 5,000 1 rupee coin. Which is efficient? 4 is efficient. Because they are asking us the minimum. They are not asking us the maximum. Yes. So the core logic is we want to go from higher to lower. Can you understand this? Because whenever we are going from the higher to lower, absolutely the answer will be what? It will be a minimum number of coins. Okay. So the logic behind it is, if they have given the 43, then we want to just traverse this. First of all, whether this 2000 is less than this 43? No. So I cannot take 2000 note. So just go here. Whether 500? No. Whether 200? No. Whether 100? No. Whether 50? No. Whether 20? Yes. Yes, because 20 is less than the 43, which means I can take 20 rupee note. Yes. So I will be taking this 20 rupee, so that I will be adding 20 to my resultant one side. And also in this 43, I want to minus this 20. So the result will be 23. Again, check whether this 20 is less than this 23. Yes, it is. So just subtract it. So it will be 3 and add it to the resultant. Okay. Now 3 is less than this 20. So just move apart. Whether this 10 is less than 3, no. Just go 5, no. This 2, yes. So at this point, I want to add this 2 here and subtract this 2 here. So resultant will be 1. 1 is less than 2. So don't go. Just move forward. So it will be 1 and 1, which is equal to 0. Whenever I get 0, not specifically at this point, sometime we may get 0 previously. For example, if it is 4,000, here itself I will be getting 0, right? So whenever I am reaching this 0, just stop here. We will be getting our answer. Okay, fine. So what is the time complexity? So time complexity will be maximum of the number of denomination we are taking here. Okay, it will be something like n, the number of denomination, the minimum number of coins we are taking, right? So that will be my time complexity. And what is the space complexity? It will be O of 1, because here we are taking these as our constant space. I will be taking these elements inside my array. Okay, inside my array. So this array size is fixed. So this will not come into my space complexity. This is my constant space. So this is my space and time complexity. For your additional purpose, okay, I want to tell you why we are going with greedy, not with backtracking or recursion approach. Okay, this is for additional purpose only. If you don't understand this, okay, it's fine. Up to this it is okay, but for your additional purpose, when you are going to the technical HR round, okay, that they may ask why you are using greedy. You may use recursion or backtracking too. Yes, why specifically this greedy? Okay, so basically whenever the question is about a combination type, like what is the minimum number of some picks, okay, like this coins, what are the coins you will be picking or selecting. So whenever these kinds of keywords are there in your problem statement, it will be combination type, right? So whenever this strike out, maximum all problems will be comes under either under greedy or under backtracking or recursion approach. Okay, fine. So why we are using this greedy over this backtracking? Basically, greedy is a efficient approach. First of all, greedy is a efficient approach. Then why we are using this? Whether it is an inefficient approach? No. Many of them are thinking like, if greedy is efficient, then absolutely backtracking will be inefficient, right? But sometimes greedy will go to the wrong path, wrong answer, but backtracking or recursion approach will not go to the wrong answer. Okay, I will be telling you with some example. Okay, so it always follow the uniformity concept. What is my uniformity concept? If I have 1, 2 and 5 and I am telling you, you have to form something like 23, okay, or let us take a small number, it is 8, okay. So 8. Now when I am asking you to just take the smallest possible values to form this 8, then what will you do? You will take this 5 at first, the same denomination algorithm, okay. You will be taking this 5 first, and what will be the answer? It will be 3, okay, and go to this 2, and this 2 will be minus here, so now it will be 1. Now again go here, it will be 1, now it will be 0. Yes. Why it is so? Because just listen this carefully. By using this 1, I can form 1. By using this 2, I can form 2. By using this 1 and 2, I can form 3. Yes. By using this 2 and 2, I can form 4. By using this 1 and 5, I can form 6. By using this 5 alone, I can form 5. By using this 2 and 5, I can form 7. So I can form all the numbers by using these 3 combinations, right? So because of that, the uniformity concept is followed here, so that we can take the highest number to the lowest number, okay. But sometimes in questions it is not followed. Whenever it is like 2 and 5, something like 2 and 5, now it is 8. Now you will be taking this 8 as 3, okay. Now go here, it will be 2, again 1. Now the answer is what? 1. So we need 1 rupee. It means we cannot form this 8 from this 2 and 5 combination. But whether it is correct? No. We can take 4 2s so that it will be forming the 8. In this case, greedy failed. So in this case, greedy failed. So these are the cases where we will be preferring the backtracking and recursion approach over the greedy. Okay, but always the efficient approach is greedy, but at some time the greedy fails. At that time we will be going for the backtracking and recursion, and that will be further gone to the dynamic programming. I will be clearly stating whenever there's a dynamic programming in this series. Fine. So this is for your additional information for your technical HR. That's it. Apart from that, it is unnecessary. Okay. Fine. Let us see the code so that it will be more clear. So Java is the preferable coding language for Zoho. So see here, first of all, I'm taking a list of integers result as a new array list. Okay. Fine. Now int array of denomination is the given denomination. This is the denomination they have given. Now I am iterating to the denomination, and while the n value is greater than or equal to the denomination, given denomination, when this condition is true, then what should I do? I just go and subtract n from the denomination. Yes, and I will be adding the denomination to the result. Fine. Now at last I will be returning the result once this 2 loops is executed and terminated successfully. So let me submit it. Yes, it is submitted successfully. To know about these kinds of algorithm, just go and watch my YouTube channel, where you can find more and more useful videos and more problems that are solved with multiple approaches for your intuition purpose. And just watch this entire playlist to know about the Zoho interview questions. Okay, thank you.